This is the tutorial for the read summary statistics using Nanoplot on Galaxy. We will be using the fastq.gz files that were made after super accurate base calling. Before running the analysis, let's go over some quality control terms. The N50 is the shortest read length at which 50% of the total base pairs in the sequencing data are contained within reads of that length or longer. The Q-score is the quality score assigned to each base call, representing the probability of an error occurring at that position. You can see in the table below that a Fred quality score of 10 contains an error in 1 out of every 10 bases, or a 90% accuracy. A Fred quality score of 20 has an error in 1 out of every 100 bases, for an accuracy of 99%. Nanopore can achieve a Q-score of 20 or higher. In this tutorial, we will be using Galaxy, which is an open source web-based platform with a wide range of bioinformatic tools. Each account is provided a 250 gigabyte disk quota for free. You can see on the left-hand side, you can upload data. You can search for various bioinformatic tools. And on the right-hand side, you can add a new history or switch between histories. Let's make a new history named Beigetrus. This is named after the phage that we're using. So save. And now we can upload our data. So I'm going to click upload. You can either drag or drop the files here, or you can choose local files here. I'm just going to drag from my other screen. Drag, drop. It will auto-detect the type of file, and you can click start. So we'll begin the upload. You can see on the right-hand side, it originally was gray in color. This shows that the files are in the queue to be uploaded. The tan files are currently being uploaded, and the green files have successfully been uploaded. So you can see all three of these files have already been uploaded. Now let's go to the search tools and let's search for Nanoplot. Click on Nanoplot. Since we have three files, we'll need to change the select multi-file mode from batch to combined, and then we can select all of our files. So 0, 1, and 2 is already selected. So 0, 1, 2, we've got our three files, and then we can click Run Tool. So you can see this is waiting to be run. Now it's currently running, and this should only take a minute or two. It's pretty quick. But I have run this previously, so we'll go there. And for the outputs, you have an HTML report and nanostats. So to view the HTML report, we'll click this eye icon. You can see the summary statistics prior to filtering and the summary statistics after filtering. Taking a look at these are the total number of reads, number of bases, median and mean read length, the N50, the mean quality and median quality scores. You can see the median is over 20. And then we can also see how many reads are over 10, a quality score of 10. So all of the reads were over a quality score of 10. 92% were over 15. 61% were over 20. About 5% were over 25, and almost 2% were over 30. So if you keep on scrolling, we can see various plots. So take you down to the non-weighted histogram of read lengths. So you can see the read length is on the x-axis, the number of reads is on the y-axis. And we can see that some reads are about 54, 55,000 base pairs. So phage Beatrice is about a 54,000 base pair genome. So these reads likely represent a large, at least a large portion of the genome, if not the whole phage genome that's been sequenced. And if we keep scrolling, we can see some of the quality scores. So for this one, we have on the X, the read lengths and thousands of base pairs. On the Y, we have average read quality. And as we saw above, the median was about a little over 20. If you want to save these plots, you can click the camera and download a PNG. You can also save the nanostats. Let's click on the eye. So this is all of the information from the HTML report. You can download this in tabular format if you click on the nanostats and then save this document. It'll save in a tabular format and you can open it up in Excel. So this has been how you do quality control of your reads with Nanoplot on Galaxy.